Today we are discussing the F-test. Ralph and Chuck work for Alpha Phi Analytics, which is a financial company based in Los Angeles, California. They have put together two portfolios of stocks. One stock portfolio consists of stocks sold in foreign emerging markets, and the other portfolio consists of stocks that are small cap and high risk that are listed in the Russell 2000 index. Ralph believes that the foreign emerging markets portfolio has higher volatility, greater standard deviation than that of the small cap portfolio. Ralph decides to ask you, as the newest employee, to help support his claim. He said that a promotion could be possible in the near future if you helped him to determine which of the two portfolios are more volatile. You decide to collect 6 months of data consisting of the monthly rate of return for each portfolio. The data is listed below. So we have the rates of return for emerging markets and small cap. Next, you calculate the standard deviation and sample size of each portfolio using your trusty calculator. The standard deviation is 4.47 for emerging markets, sample size 6. For small cap, the standard deviation is 3.31, sample size is 6. You hazily recall that to test two standard deviations or variances, you must use the F-test. The F-test is based off the asymmetrical probability distribution known as the F distribution. You rapidly draw its graph and begin to search for your old unit packet that surprisingly you find at the bottom of your desk. And so here we have a graph of the F distribution. As you read the packet, you write down the key properties. All F values are positive or zero. There are no negative F values. The area under the curve equals 1. So for any F distribution curve, the total area is 1. The distribution is skewed longer to the right. And it's actually a family of curves. So there's no one curve that represents the F distribution. It's a family of curves based on degrees of freedom of the numerator and degrees of freedom of the denominator. You write down the claim using population variances of the two portfolios. So when we perform the F-test, we always have to compare the population variances. Also, you assign subscript 1 to the data values with the larger sample standard deviation. We've already done this. The larger sample standard deviation is 4.47. The reason we do this is that the tables with the F values only list the right critical values. So for this example, the claim is that sigma 1 squared is greater than sigma 2 squared. That's the claim. H naught is that sigma 1 squared equals sigma 2 squared. Next, we select an alpha, 0.05, compute degrees of freedom of the numerator, n1 minus 1, and degrees of freedom of the denominator, n2 minus 1. 6 minus 1 is 5 for both. Now we look up the critical value in table H. Couple things to remember. If a particular degrees of freedom is not listed, then use the closest value on the smaller side. If the test has two tails, that would be the situation when this is not equal to. That's not the case here. But if it does have two tails, divide alpha by 2 and focus on the right tail, as no left critical values are provided. So let's look at table H. The first thing we need to do when we examine table H is we realize it's composed of different alphas. So we have to search out the alpha we're testing for. and that alpha is 0.05. In the upper row, we look for degrees of freedom of the numerator. That's 5. This column to the far left side, we search for degrees of freedom of the denominator. That's 5. And so at their intersection, that is our critical value, 5.05. Next, compute the test point. The test point is f equal to s1 squared divided by s2 squared. So we calculate this using our sample data. 4.47 squared divided by 3.31 squared, that's 1.82. And so finally, we make our decision. Recall, 1.182 is not in the critical region because it is less than the critical value. So do not reject H naught. There is not enough evidence to support the claim. And that concludes the video.